Everybody for coming in the evening. So the agenda for today is we'll kind of go over what big data is about. Kind of there are multiple definitions and all of them are correct, but we'll give a more comprehensive description of it. And then the next topic would be how is it relevant to our organizations? One of the observations was the biggest impediment to start big data projects is unable to show value to the business. So us as technologists should be able to, beat that impediment. Then we'll kind of introduce to the Hadoop ecosystem. There are a lot of frameworks, so we'll kind of go over them, and then some industry standard use cases that have been leveraging Hadoop. So I'll kind of go over that so that kind of helps you guys think how we can leverage at your organizations. And then Jiang built a demo from a public data set out of City of Chicago, and we deployed it on Amazon in a multi-node cluster. So we'll show you how to execute that and do a demonstration. So from a definition perspective, I was recently talking to one executive and he said, hey, we recently engaged with IBM and Deloitte. We gave them 100 data fields and said, this is what we are building our analytical reports from. Tell us how big data can help us. And from his perspective, he was thinking, today we are only using data of 1-year-old or 2-year-old. With big data, I'll be able to use 10 years worth of data. And from his perspective, it is true. So that is one characteristic of big data, but it's a lot more comprehensive, right? So Wikipedia defines it as the size is huge. And common tools like your relational database reporting tools, they will have a hard time to capture that data and generate reports out of it. Gartner's definition is what predominantly is considered the industry standard. It is data that has one of these 3 characteristics or all combined. High velocity, they're coming at a very fast pace. Stock ticker data or this Internet of Things, sensor data just coming in. Different variety, the data could be Twitter feeds, the data could be, images being posted on your Facebook pages. So multi-structure, right? So it's not, one particular schema. And then heavy volume, right? It could be large data, from years worth of volume. So, and another definition is, any large volume, unstructured data which cannot be handled by traditional database systems. So this is the NoSQL guys definition, multi-structured, not relational databases. And if you have questions, please, stop, in the middle. It's good to have discussions going on. So, in my opinion, Hadoop and big data is a game changer, and I'll kind of build on why that is the case. So, first thing is, right, we are used to building applications where we know the schema, right? But here, with big data, as we said, data could be of any structure. So when I'm writing data, I don't care about what schema it is. So, but I will care about it when I'm trying to read and analyze the data. So it's schema on read versus a traditional schema on write, right? And my schema could be different than somebody else's, right? So each application, can have their own schema. That's, the other, side aspect that I wanted to emphasize. And so then the other part is today, right, we are, when you're building distributed systems, we always bring data to our, middle tier to process it. and data is huge, our code is small. So these guys, they change the paradigm where I am moving the jar file to where the code, where the data resides. So moving the code to data, right? And then, the other key aspect is, and this is what Google and these guys take advantage of. They just have a lot of data. I don't need to write complex algorithms. If I have the data, a simple algorithm will suffice for me to address my needs. So these are, some 3 areas. So in terms of, how it is relevant to our, organizations where we work. So Forrester did a study, and they say that only 12% of data that is actually being provided to a company is being harnessed. So there is this tremendous amount of data that is leaking, right? And there are different reasons for that, right? Why we have been ignoring for the past decades is high cost. We cannot put them in an enterprise SAN. It's very expensive. And if I want to process all that, I don't have that many CPUs, or I'll be paying the software vendors, for those CPUs, right? And the key benefit is future-proofing your business. So when we, were building web services, we used to say we are future-proofing our architecture. It's like before web services, client and the server have to be on the same language. Now the client could be anybody. I am future-proofing my service. But this takes the future-proofing to the next level, right? Because as you can see, businesses evolve, business models are changing. But if you have the data, I can figure out how to use that data later, right? And the schema on read is giving you that ability to do that. When I am building my application or when I am loading the data, I really don't need to care about how it might be used. And that just opens up a whole window for us to leverage the data that we have been accumulating. So in terms of motivation and the history for big data and Hadoop, so the last 10-15 years, the storage capacities have increased, but the access speeds or the latency have stayed the same. And the big internet companies, they were the first guys who actually started facing this problem, which is they were just getting so much data that they need to analyze the clickstream data, and they needed a high-speed parallel processing platform to be able to process this data. And Google published this MapReduce architecture in 2004, and that actually generated this open source project called Hadoop. So MapReduce framework is the processing engine. So basically, think of it as, I have a large job, I'm going to split it, and I'm going to, do these chunks in parallel, and then I'm going to combine it and generate the output. From a conceptual perspective, you're just, breaking it into tasks and, processing it. Right. So now let's get into the Hadoop ecosystem. So let's start from the bottom. So HDFS is the file system. So this is, we'll go into the details of HDFS, but think of it as your regular file system, and this is where your files that will be processed, will be, located. The processing engine is the yarn MapReduce, and so one of the key things, right? The common use cases in a company's journey of Hadoop. One of the first use cases is ingestion of the relational databases into Hadoop, so into HDFS. So basically, I have this 20 terabytes of data that is sitting in my warehouse database. I don't have the processing power to analyze that. So you can use this framework called Scoop to ingest or import this structured data into HDFS and then run these parallel processing algorithms to analyze it.
So quick question here.
Yes.
Scoop, when it is ingesting it.
So we can do import and export.
Import and export.
Yes.
So, but for the export, I would anticipate some kind of a mapping capability, mapping.
You will have a serialization, deserialization of plugin that you could. And you're defining the schema on both sides.
Right. Whereas here, it's not a schema that's on write, but it will be on read.
Yes. I mean, but you are dumping into HDFS, but then you will apply a structure, right? When you are trying to analyze it through Hive, you will.
Then you will apply the schema.
You will put the structure on top of it.
But when it's ingesting it from structured data,
yes.
Is there anything that it's doing to disseminate the data into HDFS?
It will. So when you are running Scoop, you will say, this is the structure of the file that I want you to put in as.
Okay.
So there you will say it's comma delimited, or these are the and then there is a serialization framework, and the most popular or performant one is called Avro, and that provides you the serialization deserialization framework. Then the next one for ingestion is Flume. So Flume is a framework where if you want to get streaming data, like log files, you want to consolidate those and store them in HDFS, Flume can help you do that. HBase is the NoSQL database in Hadoop. All right, and Hive it's your warehouse environment. So basically, it's providing you a SQL layer on top of files that are stored in HDFS. So this is what is democratizing your data, because you have a lot of business analysts in your company who only know SQL. So if you ask them to, we need to analyze this data in HDFS, they need a programming, or they need a tool, right? So they know SQL, so you use Hive for that.
Good question.
Yeah.
Is Hive also for input as well, or just for output? Only for analytics, or also for inputting data into HDFS?
You don't. You can load, but it's mostly for analysis. So Pig is what you would use, to load, or Scoop. Hive is mostly for your. You can do so. You cannot update records.
That's what I was going to. Insert statement updates.
Not DML, right?
Insert you can, but again, that's not your typical use case.
Sure.
But updates, no. If you want to do updates, you'll have to use HBase.
You said it uses structured query language. I mean, by definition,
Hive.
data is unstructured, so it takes care of.
Good
how
question.
that-
Good question. So basically, what you need to do is you will define the schema, because schema on read, right?
Okay.
So schema on read. So you are writing a Hive query to read it.
Right.
So you will construct a structure on the data that is there. So you can define the structure, which is your schema, and then you run the queries which use that schema.
So
That's
that
the
has to
idea.
be done before you can.
Start issuing your queries.
Yeah,
Yes,
you
yes.
can give it out to your analyst or whoever.
So basically, there is a H catalog. There is a metadata store.
Okay.
So you can define that structure there, and then people can use your Hive tables. So then they become like tables. So you're basically, so in the demo, Lan will demonstrate that basically he loads a file and then creates a structure through H catalog, and then Hive. So they show up as Hive tables, and then you're just writing SQL.
Yeah, we will demo H catalog, Hive, and Pig, all of them. So.
Yeah. Okay. And then R connectors. A lot of statisticians use R. So here is your R directly talking to HDFS. Mahout is machine learning. So if you're building a recommendation engine, right, like Amazon says, if you like this book, you would like that. That's an example of a recommendation engine. So Mahout has the libraries for machine learning to do that. Pig is a scripting language through which you could do ETL. That's a very common use case. And I'll get into more detail on each one, based on how we're doing on time. So Oozy workflow, this is the workflow engine where you can schedule jobs. So you can say, run this pig script, after that run this hive script. So you build this workflow, and you can also schedule it like a cron job, run it at 5 a.m. every day. So that's what Oozy does. Zookeeper, you can see it's all animals, right? So Zookeeper is doing the coordination and is doing your distributed locks. So HBase, has a bunch of region servers. So Zookeeper is the one that manages those.
So one question here.
Yeah.
Given the fact that HDFS is primarily schema-less and it is data and you have defined the data on read, what kind of a strategy do you really need? What is the use case for introducing locks in such an ecosystem? I mean, why would you, can't I technically ingest data as users are reading from it? Because the predominant use case is for users to read through these various tools.
Yes.
Make sense out of this unstructured mass of data, right? So technically speaking, you should be able to ingest data continuously.
Yes, you can, yeah.
So what are the use cases?
So for the distributed locking, it's used in HBase because they do partitioning for different areas. And then when you are dropping a table and stuff like that, they lock it. So there is still, there is still atomicity at that level. So, that's your distributed locking service. And then Ambari. Ambari is your management console. Can help you, deploy and provisioning, and also gives you a management console to look at your, the health of your, job trackers and your name nodes and your data nodes. So let's dig into the HDFS architecture. I wanted to see the time.
Were all those components from Apache? All of them?
Yes. Yes. All. Yeah. So the entire this is all Apache Hadoop ecosystem, and there are competing technologies for the same use case, and I have some slides that kind of go over that, because part of our job would also be for a certain use case, which framework is the ideal use case, because there are some some subtleties, and then some guys do a superset of the other guy, but for some use cases that subset thing is way better. So yeah, but all of them is open source. So we can discuss this now. So there are two major vendors, Cloudera and Hortonworks. So Apache Hadoop is open source, right, as we discussed, but IBM has their own. Now HP, everybody is also providing the big vendors. But the guys who have the major market share are Hortonworks, which is a spin-off of Yahoo. So Yahoo was the main guy behind Hadoop. So they spun off and they went public a couple months late last year, I believe. And so they sell a commercial product, on top of Hadoop. And then Cloudera, that's the biggest market leader. And there is another one called MapR. So yeah, and then there are other companies, Pivotal and these other guys, but Cloudera and Hortonworks are the two major players. So HDFS architecture, right? So HDFS is Hadoop Distributed File System. So distributed file system, what does that mean, right? So let's say that, so first of all, what is a use case where I need HDFS, right? Let's say I have a 100 terabyte file. That file I cannot store in a regular file system because it's just too big. So that kind of file I can store in HDFS. How can I store it in HDFS? right? What it does is the name node will break it down, so will as chunks, and then distribute those chunks into multiple data nodes, and then he maintains the metadata of which block lives where, right? And as we said before, I think Dan was mentioning, the boxes they bought were each $5,000, right? Commodity hardware,
Gas, yeah.
right? So the idea is you're building Hadoop on commodity hardware, meaning cheap hardware, and you're not using the expensive SAN. So using your just a bunch of disks, right? And those disks can fail. So that's why they provide replication, because they need the high availability. So by default, if you have more than 3 nodes, he replicates in 3 places. So if you have 2 racks, they would first put it in one and then copy it to the next rack and then make another copy on the same rack. That's the default. And then when a client is trying to read, so he will first access the name node. Think of name node as like your JNDI. So and then he will get information on which data node he needs to go, and then he starts reading from there. And in terms of writing, again, you are writing directly to the data node, and then there will be replication going on behind the scenes for you. So you never send any data to the name node. You're always writing and reading and writing from the data node. But the name node. So there are a name node is kind of a single point of failure. With Hadoop 2, they made it better, where they have a standby name node. But name node is very important because he keeps track of all the metadata. If name node goes down, your entire Hadoop cluster is
That's what
dead.
keeps track of the distribution.
Yes. Yes. So he has the name node has a FS image and an edit log file. But so the FS image is in memory, and then the edit log is the one that keeps track of the changes. And then there is also a secondary name node. And secondary is a really bad name. It should actually be called checkpoint node, because what he does is he's reading the edit log from the name node, and then he builds that image, and then he pushes that image to the primary name node periodically. But still, it's not a secondary name node like what you would expect. So now with Hadoop 2, they have a standby name node which does what secondary name node does. And I think in the Lance demo, he also has the secondary name node. He set up the cluster that way.
Vijay,
Yes.
if, for example, if the data node fails, what will happen?
If a single data node fails, no problem, right? Because the data is replicated in 2 other places.
How the name node will listen that data?
Yeah, so basically, every data node sends heartbeats to the name node. Yeah. And yeah.
Do you lose storage space? Like it's like a RAID where
You don't need to use RAID, right? Because they are doing the replication for you.
But do you lose storage space because of the replication?
Yeah, absolutely. So you are paying 3 times the storage. So for one of the comments that one of our friends who works with this Cloudera Hortonworks said was, the guys who are making the most money are the commodity hardware vendors, because everybody is building these
3 times.
Yeah. So let's talk about MapReduce framework. So the whole idea is, so we were talking about this 10 teradata file, right? So if we need to find some patterns in that file or something like that, right? So what you would do is, so first thing is, that file would be split into chunks, and they would go into different data nodes, and then you as a developer have to write the map function and the reduce function. Okay, and in that map function, so this is where you're doing parallel processing, right? So the idea of map is it's a key value pair. It takes a key and a value and it generates another key and value, right? So that's the functionality. So here the framework does the sort and shuffling, and then the input comes to reduce, and you can have multiple reducers. So as a developer, what we have to write is the map function and the reduce functions. All right. So Hadoop 2 is a significant improvement over Hadoop 1. And why is that? Hadoop 1 was all about batch jobs, because everything that you we'll talk about pig. We talked about pig and hive, right? And I talked about hive being a SQL interface. So the guy who's writing the SQL, he expects an interactive response. He expects an answer to come back within a couple seconds. But then internally with the old Hadoop 1, everything was a batch. The startup time itself used to take seconds. So if your requirements were in the milliseconds, you're already lost in the battle, right? So the use cases that Hadoop was used for was just a subset of our real world use cases, right? So with Hadoop 2, what they did was in Hadoop 1, the MapReduce that this engine used to do resource management, meaning which data node should be processing this task. And it also kept track of the job. So there is this class called job tracker, and you have so job tracker lives on the name node, and task trackers live on the data node, and the task trackers give the feedback to the job tracker, right? So MapReduce was doing both application management plus also resource management. So with Hadoop 2, they divided that. So they have Yarn, which stands for yet another resource negotiator. So he is just responsible for the resource management, which node should process the task. And then you can plug in your application framework, and that is MapReduce. And here, he was just focusing on, the application. So there is instead of the job tracker and task tracker, here you have a application master who lives in the data node, and he is keeping track of all the tasks that are running, and then he gives feedback. So because of that, they were able to plug in other application engines. So Spark is a competing technology or a competing framework with Hadoop, but I can run it on top of HDFS. So before, because the whole thing was tied together, you could only run batch jobs. Now with Yarn, I can plug in my own application framework. So Spark is an example, and MapReduce too, and then I'll talk about in the future slides where companies made Pig and Hive run faster by leveraging this division of responsibilities. So MapReduce, it's a restrictive programming model, right? The only inputs are key value, the output are key values, and the only coordination you can do is again just pass the key and value. And even though it is very powerful and people consider it as a general purpose data processing tool, if you think of if I want to run a query, if I have to run a MapReduce job, that deployment and all that is going to take a long time. So they really needed higher level abstractions than have people resort to writing MapReduce jobs. So today, I wouldn't think most people using Hadoop would be actually sitting and writing MapReduce jobs. They would be using higher level languages. But all those higher level languages would generate MapReduce jobs. So for us, when we are debugging and troubleshooting, it's important for us to understand the concepts. But you really don't need to, program and call and execute these functions of map and reduce, because when you're really trying to solve, when you look at these word count examples and stuff, yes, they look simple. I just write the map function and the reduce function, and voila, I get the results, right? But in the real world, you would actually have to write multiple map reduce pipelines, because again, at the end of the day, I need one output. To do one output, I can only have one reducer. So, so I have multiple pipelines. If I use something like Pig, they generate it behind the scenes for me. So that's the key advantage.
So one question here. I mean,
Yeah.
what's the general? Are you running short?
No, we're good. Go ahead.
So for the what's the overhead introduced by these higher abstractions and other things?
I'll get to that. Yeah, good question. So you're at 7. So we have half an hour. So Pig is a high-level scripting language. So when Lan shows you the example, you will see it's very easy to follow through. It's like a data flow language, and like analysts can see it, and then you can also plug in user-defined functions. Which if you already have written, we can plug those in. And since it's running in a JVM, our Java programs can also call these Pig scripts. The predominant use cases, like as I said before, are ETL jobs. So some of your companies might have Teradata licenses for their massive parallel processing, but Teradata is like 100 grand a CPU, and some of them do ETL in on Teradata. So one of the use cases that people are doing is moving all that data into HDFS and writing Pig scripts to do the ETL. So that saves them on CPU licenses on Teradata. And then the most common use case is I just want to explore data. I'm a business analyst, and I just want to see. I want to do a what-if analysis. Is there a correlation between this and that? I don't want to sit and write a MapReduce job, compile it, and send it, and then wait for it to get run, right? And because I'm not going to run it forever, I just want to run it today, and it's not useless. I just move on. So it's like so you need a scripting language. So the data analysts write these Pig scripts, and then they throw them away. So these are like your your grunt shell. So they give you a shell also, and that's called the grunt shell. And there you just do your command line and explore data, and you can generate output files that you can use for other stuff. So Mook was asking about the overhead, right? So MapReduce, because Pig is interactive, because I'm sitting at the terminal, I'm waiting for it. Before, it used to be really slow. You run the query, you go get a cup of coffee, and hopefully it will be over. And I have to say, if you guys use Hortonworks Sandbox, I felt it is still the same case. Maybe the sandbox is not configured properly or not, but Pig is pretty slow. So what Hortonworks did was, after Hadoop 2 came, they created a new framework or new engine called Tez, and that runs faster. So the whole idea of why it is slow is, the fundamental problem with MapReduce is, as I said, right, with every, most of the time we are joining two tables. Whenever we are trying to explore, analyze data, you're joining two tables. With MapReduce, that means trying to run joins by doing native MapReduce programming is very hard. So these higher level abstractions help you with doing the joins, but then you're running multiple MapReduce jobs in a pipeline, and all of them are writing to the HDFS files and then reading from it. So that's a very, writing to disk. So startup of the job engine, then doing the job, and then writing to disk. So those are what was taking time. So what they did with Tez, which is Hindi for Tej. So there are a lot of Indian guys in the Hadoop ecosystem. So a lot of names, as you can see, have the Indian pedigree, Ambari and Mahout, right? So Tez does all that in memory. So that's how they get the speed. So we actually ran tests, with it's just a command line option. You can say run with the classic MapReduce engine or run with Tez engine, and a 20-30% improvement. So Hive, as we discussed, is a framework for data warehouse, but the key thing is SQL access on top of HDFS, and and it had the same issues. Hive looks good, but then at the end of the day, it's executing MapReduce jobs, and people thought it was slow. So what Cloudera did was they built a competitor to Hive called Impala to run for these interactive query use cases. What Hortonworks did was they thought Hive is a very good tool. We don't like programmers to say, oh, I'm running an interactive query, I need to use this one. I'm running a batch query, I need to, I need to use Hive. So their philosophy is, let me run one query, people have already invested in Hive, and depending upon the query, we will figure out what engine we need to use, and then we'll use that. So that's the approach they took. And then again, we did the comparison with Tez, without Tez, and it is fast compared with before.
But even if you're doing it in memory, it will take time to seed it, right? In memory, because we're talking about large amounts of data, even with a large memory.
Yes.
Ecosystem,
Yeah. I mean, they made it faster, so the relative time is
So for you to, based on the use case to do that swap, you need to have preloaded it in memory for you to even consider Tej as an option.
Right. So that's where I was going to talk about Spark. That whole thing is in memory, and they have resilient distributed data sets, and they're like competing with Hadoop. I'll kind of get to that, but again, the problem is the size of the data, right? So,
Quick question.
yeah,
Are these tools expensive?
they're all free.
No, not the Apache ones, the Cloudera and the other ones.
They're all subscription based, so you're just paying for support.
I mean, yeah, but are they expensive?
What I heard is list is around $5,000 per node.
That's only support, right? Not subscription. I mean,
Subscription.
It is subscription. I mean, it's like they give you, so Cloudera, everybody has the open source version, right? They built management layers on top of it, so you get all that, but then you're paying for the support. So we talked about the NoSQL database for Hadoop is HBase. It's based on Google's Big Table. So it is a column family NoSQL database. So what that means is, with relational database, right? We call it row oriented. When I do a select, I might only need column 1 and column 2, but it's going to load the whole row and only going to give me what I asked for. So for a large row one, it's very inefficient. So column family is, they call it columnar, databases. The idea is you define a column family, you define multiple column families, and within that column family, you can add any number of columns whenever you want. That is how they are giving you the flexibility of adding what you want. But you have to define the column families up front. So it is more richer than a, this JSON, MongoDB, key value, database. Again, a lot of people use Cassandra also with Hadoop. So I mean, HBase is what is considered, but Cassandra also is open source, and so Cassandra also is can be considered as part of the Hadoop ecosystem. And the use cases is as Pankaj, as you asked, how do I do updates, right? If I have to do updates in real time, I have to use the database, HBase, right? Because if I want atomic, I need that. And as I said before, Zookeeper uses HBase uses Zookeeper. Zookeeper is the one that gives you the distributed locking and gives you the partitioning. And the other thing about NoSQL database is there's something called CAP theorem, which stands for consistency, availability, and partitioning. And the idea is you cannot have all three of them. You can only have two. So, for example, everybody here must have used Amazon. So Amazon uses DynamoDB for their persistence, and those guys don't have strong consistency. They have eventual consistency. What that means is, like, let's say you put some items in your shopping cart. Because they are highly available, they are partitioned in multiple places. The other replicas don't have your update yet. They will eventually get it. That's what eventual consistency means. Most of our OLTP systems, we want strong consistency. So HBase provides you strong consistency. So that's just like a sidebar. So we talked about Scoop. Scoop provides you the import-export from structured data. Before it used to be only relational databases, but now Couchbase has a driver for it. So even the NoSQL databases. So you could import it to HDFS, or you can import to Hive directly. So which is what the typical use case would be. I have this structured data in Oracle, but my queries are running 2 days. I want to move that to HDFS. So you just use the same structure that you have here. You put it here, and then you run your Hive queries on it. Right? So they use the JDBC driver to get the data types. So this whole thing is written in Java. The whole Hadoop ecosystem, pretty much. And it uses serialization, deserialization, we talked about it. And even this, the loading is actually being done by generated MapReduce jobs. So that's how you're getting the performance. So Apache Flume, this is what we discussed, where if you have a use case where you want to pump the streaming data, like log file stuff from your 100 web servers into HDFS, so that we could analyze and do clickstream analysis. This is a perfect framework for that. So basically, on every web server, you will have a Apache Flume agent, which is basically sending these events, which are your log entries. They write to a channel, which is like think of it as a queue, right? And they maintain the integrity of it, that the message will not get lost. So basically, unless the sync writes it to another channel, this will stay put. So you won't lose your messages. So the whole idea is, if you have hundreds of web servers, you run the Flume agent on each one of them, and then consolidate to one guy, and then write to HDFS, and then do the clickstream analysis.
The secondary layer is just for consolidation?
Yeah.
So what is the use case for consolidation? Just why do we need consolidation?
Is so that if you want all of that to be as one single file, because because again, all of them will come in as different slices, right? But I want between 10:30 to 10:45, I want the data from everybody, because all my queries here, I don't care about which machine they came from. I'm concerned about the time and then the user ID and stuff like that. Right? So since we are Java developers, when we were looking at Hadoop, I was with Hadoop 1, I wasn't that excited because I was like, this is for the ETL guys, this is the next generation ETL. Yeah, go ahead.
In the previous slide, I had a question. You said it was just for consolidation, right?
That is one use case.
Okay, so
So, I mean, it's like if you want, you can make this guy directly write to HDFS. You don't need this part.
so let us say in my system, I have this consolidation setup.
Okay.
But I want to analyze the data from that specific, server. So let's say there are like 7, 8 servers which I'm consolidating.
You only
I would
want
like to just only get this guy.
So you would filter, so basically in your HDFS, one of the columns should be your IP address. And then you just run your SQL, Hive queries. I mean, LAN actually at Delta implemented MongoDB for trying out. And, at Vertafore, Dan implemented using Elasticsearch. So that was the presentation he gave last month. And Flume can do what he was doing with that stack. I thought somebody else had a question. No, okay. Yeah. So before Hadoop 2 came into picture, I was following the Hadoop ecosystem, but I was like, this is more relevant for the data guys, the ETL guys, because this is the next generation, warehouse. But with Hadoop 2, now, because we are, very familiar with our, publish, subscribe, loose coupling, and processing, complex events like event processing. I mean, this is our, domain, and Hadoop can help us with these frameworks. So basically, there is a open source project called Kafka. So Kafka, provides you this distributed, pub sub infrastructure, right? So basically, you will write a Kafka producer to publish messages and a Kafka consumer to consume events. So there is an open source project called Apache Storm, which would be the one that will be consuming the messages from Kafka. So the idea here is I have these real-time events coming in, it could be Twitter feeds, could be Facebook, and I want to process it and then, write to HDFS. And I want it to be really low latency. That's the use case, right? So it has a real-time computation engine. So this is like your classic CEP engines. It's very similar. So consumes data from spouts. So spouts are, your Kafka topics, right? And then it will do some processing and pass the data to Bolt. So this is the terminology of Storm. So Bolt could be a HDFS or could be another topic. But the idea is if you're doing this analysis, it will be HDFS. And it can run on top of Yarn. And Storm also, it uses Zookeeper. And the key thing is it is a true stream processing engine. There is no batch processing going on here. So if you have low latency ingestion requirements, this is the framework that you can use, and it can support the JMS semantics that we are familiar with. At most once, at least once, exactly once. So
but does it also support the other temporal operators like as an operator, where to say event comes between this event and this event or event?
I don't know.
Those kind of things.
I'm sorry, I didn't get the.
Like typically the CEP engine, it supports semantics wherein you can compare events. That's what they do. When you have a lot of micro events, the biggest value add from a CEP engine is to be able to do consolidation and collaboration between the events to fire off certain business.
So like queries which can say, did this event happen before
within the
that?
last, so many seconds. Or,
Do you mean like a small sliding window so that
sliding
you can
window,
compare?
or you can say if the event happens during, you can say event B happens during event A, or event B follows event A, or event B precedes event A. You can have those kind of semantics. So basically, when you are doing any business activity, when you are getting a stream of events, you can do something meaningful, because a lot of time there is some
Correlation.
controlled action and decision.
I think Storm has a component called Trident, which is kind of like similar
CEP.
to the what they call is called micro batch. So basically, it has a very small window that within that window it batch the whole event within it in one kind of like do a small batch processing, which will be a little bit more latency since they have a window, but kind of like probably can do something what you are describing. So
yeah. So you must have noticed. So yeah, go ahead.
I think the other thing with Storm is the way it distributes things is it's basically partitioning those events across different nodes.
Correct.
And you can control the partitioning algorithm.
Yes.
And each of those nodes is a stateful thing. So if the question you want to answer is something you can answer by just seeing, all the node or all the events for this, partition go to this node. So it's seen, so if the event you want to see, did it happen before this? If the thing you're looking for also would have gone to that partition.
Okay, basically you're partitioning based on the event type.
Yeah,
correct. You can partition any way you want, and you could replicate events. So maybe one event gets passed to multiple nodes because multiple nodes need to know about it. So with the partitioning, you can do some things to solve some of the problems you're talking about. If it's possible, say, okay, send all the events that are related to this topic here, and then that node could know enough to say, well, did this happen before that, or did this happen between these two other events? I don't know that there's a construct that like we're in Storm where you just say, at a very high level did this. I think you kind of have to know enough to do that in how you implement the nodes, or the logic within each of the nodes.
I think you can configure that each event you can have a key, and then the same key will always go to the same partition.
Yeah.
Right.
And you can configure on the consumer side. You can also configure like a consumer group.
Yeah. So one thing with Kafka that is interesting is, initially I was like, this is a pub sub model. How do they know when they can delete the messages? Because subscribers can come and go. Did all the subscribers get the message? And apparently, what they do is it's all duration. So you set a time limit for that message. So they don't keep track of who is producing, who is consuming. They just give it a time to live, and that's how they're getting the scalability. Right. So Apache Spark. We've talked about this quite a bit. So Spark is a totally competing technology with Hadoop. Spark came out of UC Berkeley, but all the Hadoop vendors support Spark also. So Spark, as it is a high-speed general-purpose engine for large-scale data processing, right? It's exact definition of MapReduce. But these guys are much faster than MapReduce, and it does not need Hadoop. All it needs is a shared file system, such as Amazon S3 or NFS or HDFS. Now with Hadoop too, because they have Yarn, they can have Spark as the engine instead of MapReduce. So that's how the Hadoop vendors also play well with Spark. And then Spark is implemented in Scala, and so the big thing about Spark is everything is done in memory. So with the MapReduce, I was saying you're reading and writing to files. So with Spark, it's all in memory, and they have a streaming API that competes with Apache Storm. But it's not really true streaming. It's like micro batching, because again it is a batch processing engine, but it does micro batching, so it is faster than your traditional MapReduce, and it can only support exactly once. So the reason I was saying Spark is an ecosystem in itself is because Spark has a Spark CQ similar to Hive. I don't know if they have equivalent to Pig. I don't know what it is.
They don't have equivalent.
Yeah,
No.
and then just like Apache has Mahout to do the machine learning algorithms and stuff, these guys have their machine language libraries. So there is a company called Databricks that is now, providing subscription for this, and their whole sales pitch is you don't need to set up this Hadoop cluster and everything. Give your data to the cloud, and then just write Spark programs on top of it. So that's their. So we will see if Spark really takes off. But it's relatively new.
So it is basically file system agnostic, you said, right? Mark?
Yes, I mean, yeah, it could run on any shared file system, so HDFS, or see, it doesn't need Hadoop at all. It can just run on Amazon S3.
Is it heterogeneous across the file system?
What do you mean? Like
Can I
some
span it
HDFS?
across multiple types of file systems?
Good question, don't know.
What's the question again?
So it's basically file system agnostic. Basically, it can run against a variety of file systems.
Right,
ranging
right.
from S3 to HDFS if you have Jiang.
But like the same job,
Can it-
half
can it
running on
plan
HDFS, half running on.
Once
I'm not
Yeah,
sure. Do you,
I don't know
such
if
use
it's a
case.
practical use case, but yeah.
But by the way, running on all this is not just the trait for Spark. Actually, in MapReduce 2, it can run on all these file systems as
Yes.
long as you implement certain APIs. For example, Cassandra, they have their own file system called Cassandra File System (CFS), which is implement so you can use Cassandra CFS replacing HDFS.
Yes.
Amazon Elastic MapReduce is running on S3, most of them, and that because as long as you implement that API, you are fine. Like MapR implement their own file system, so HDFS is just the most kind of de facto, but you can replace with other file system, distributed file system if you want, even in MapReduce.
Okay. I'm going to speed it up. I definitely want to spend time on these common use cases. So one of our prospects was talking about use case where today in their warehouse they have detailed records and summary records. All their reporting, they only use the summary records. They never run any queries on detailed records because they just don't have the horsepower. So that is a very classic common use case, moving the detailed records to Hadoop. And you basically build, using the OZ workflow engine and scheduling and stuff, you basically just make it a daily job. So your business analysts don't even know where the data is coming from. They always have, the latest data, right? And queries from longer duration data, meaning, before we used to only run for 1 year, now you could run for 5 years because the queries can run fast. And, diagnostics, metric information like log file analysis. And there are companies, there's one company called New Relic, which basically is a competitor to CompuWare's Dynatrace. So their differentiator is they are putting all the performance diagnostic information on the cloud, and then they store it in a NoSQL database, and they give you and they run analytical queries on it, which run really fast, compared to Dynatrace, which uses a SQL Server repository, right? Then 360-degree view incorporating clickstream data. So you are, let's say, in your web application, you are showing the 360-degree view of the user, but you're only getting that data from your relational databases, but you're not integrating all he has done on the website, right? So now you can get those access logs and tie these together. Yesterday you did this, this, and this. So this 360-degree view is another use case. And then unable to generate reports. So this is why Yahoo started using Hadoop. They just were getting bombarded with so much log files. They weren't able to generate the reports they needed for next day morning by 8 a.m. They needed these reports, and they just weren't able to do it with their Teradata and Oracle databases. So that's when they moved into Hadoop. And analyzing sensor data. So with this Internet of Things, you're getting a whole bunch of sensor data streaming, Flume or Storm. Large volume of image data, building user profiles, and then sentiment analysis. So this is using Mahout. So basically, what's the sentiment on a particular movie or a stock, and recommendation engines. That's the common use cases that Netflix, LinkedIn, all these guys when they started using Hadoop, that's one of the regular use cases. Risk analysis is another use case, and when we do the Hadoop User Group meeting, well, the Cloudera sales rep talked about one local customer who is using Hadoop for that particular use case.
Quick question, Vijay. Are you seeing any movement towards transactional processing in your research?
You won't, right? Because this is not, it's all append only. These HDFS files that we are talking about, right? You cannot update those files. You can only add. So OLTP is a different use case. So this is, processing. So basically, think of it how you can coexist with OLTP systems is you have all this data, you're doing something to generate data that your OLTP can use. But
yeah, so you're right. May not be for Hadoop, but for some other big data technologies. I was just wondering if you saw any research, any movement towards any OLTP kind of stuff also, people using it.
Yeah, you can use NoSQL databases. You can use NoSQL databases with OLTP systems, right? Because they give you the transact. You need strong consistency. That's where MongoDB, at Delta, we were going to use it.
There, it's not really very strong on asset though.
Yeah, we are using at Jackson as well, but again, it has its own set of bunch of issues. I was wondering if you're seeing any more movement and more vendors coming in that space and trying to support use cases that big enterprises might have on the transaction side.
Yeah. So, we cannot, finish a Hadoop presentation without talking about security, right? Because everybody is, when we talk about the Hadoop use case, you are, bringing everything in your enterprise onto Hadoop file system. So if somebody hacks into that, he has keys to the kingdom. So securing that Hadoop data is a very important space. So there are, vendors, that are, trying to protect data. So basically here is, a company called Voltage, which was recently acquired by HP. So the idea here is they do data masking, and basically, so all the data that is stored in HDFS is encrypted, and basically applications, so here, the applications apply data masking and then store it as if it is protected, as it is masked. Or here, applications are using unprotected data, and then the masking is done at the ETL layer and then stored into HDFS. So you have all kinds of use cases. But the idea is, when you're thinking about Hadoop and in your enterprise, because what you're putting is very important data, you need to think about security as part of your reference architecture. So in closing, before we go to the demo, the technology is in hyper-growth phase. There are so many companies popping up, and it is complex. So basically debugging these, the tools aren't, as mature as you would think. But the products are evolving. So this reminds me of the J2EE days where there were a lot of productivity code generation type of tools that came up for people to help write stateless session beans and EJBs. So here there are companies. Karmasphere is one. Datameer, for example. All these are providing IDEs, like for example an IDE to run MapReduce job locally and debug. I'll only have one map and one reduce, but I can debug, I can step into the code. And then also Datameer is about, we have adapters to connect everywhere. You don't need to worry about writing scoop, so you just plug and play. So again, for Hadoop to go mainstream, all these ecosystem needs to come into play. So what we would recommend is, hopefully you got some ideas for some use cases. So try to create a pilot project and have it as an incremental journey in your enterprise. All right, over to you, Lan.
Okay. guys want a minute?
break?
Okay, 2 minutes break.
So many, I guess, tools in the chest, I guess.